Alright, so this is 8.3b, and we are ready for the problem sets. We're going to do some of the problems from there and go from there. So let's start out with one like 22. Okay, so I'm looking for a number that I can multiply by itself 3 times, because that's what my index is here. That will give me 320, hidden 1. How about 40, hidden 1. So because of that, then I go to the next step where I try to find 2 numbers that I can multiply together and get 320, and one of those numbers I can take the cubed root of. Okay? Sometimes you end up with these big numbers, and that's even too hard to do. But there is a way to do it that always works. And so now I'm going to show you that, just because if you get frustrated with some of these bigger numbers, this is a way to make that work. And what I do is I just take this number and I find the prime factors. And this will always work for square roots, fourth roots, fifth roots, whatever. So, and I circle my prime factor to know that I'm done with it. And then 82, circle that. 42, circle that one. And keep going. 22, 10, 2, gosh, this kind of goes on and on, doesn't it? 5, 2. So there's all my prime numbers. So what I'm going to do is I'm going to write, instead of 320, I'm going to write 1, 2, 3, 4, 5, 6, 2 to the 6th power times this lonely 5 right here. Okay, so that's how I'm going to write 320. Alright, so some people look at that and like, that's too hard, I don't want to do that. It's not really hard, it just takes a little bit of time. Alright, so let's look at the next one. Plus 9 cubed root, and let's break 40 down. Now, obviously, it's going to take us long. Okay, so 2, 3 times 5. Okay, so when you do that with numbers, it puts everything in as radical, or as exponents, so it makes it nicer to do here. Okay, so what do? 3 goes into 6 how many times? 3 goes into 6 twice, with none left over, so we have nothing left in there, except a cubed root of 5. 9. 3 goes into 3 one time, so I bring 1, 2 out, I have nothing left over, and I have a cubed root of 5 inside. Alright, so let's multiply what's on the outside. 5 times 4. 9 times 2. And notice that my radicals are the same. That means I can add 20 and 18 and get myself an answer. Okay? So I hope I didn't just throw a wrench into you understanding it. You can do these many, many different ways, but this, when you get these big numbers and you're dealing with cubed roots, if you just make it into the product of primes like I did here, 2 to the 6th power times 5, 2 times 2 times 2 times 2 times 2 times 2 times 5, and then you can find out how many times this index go into this, and then pull that many out twice. So I'm going to pull 2 2's out. To me, that's the easiest way to do these, but to some, that's difficult. So what we're going to do is I'm going to try practicing a few of those with you, just so you can kind of get the hang of it. So let's jump down to 35. And this one's a fairly simple one that you don't have to go through that method, but I'm going to anyway, just so you get used to it. And I'm sorry I started with kind of a harder one before I did this one. Alright, so 24 breaks down to 12, 2, 6, 2, 3, 2. So I have 2, 2, 2. So 2 to the 3rd power times 3. This 3 right there. Okay, so instead of writing the square root of 24, I'm going to write it as 2 cubed times 3. So 12 breaks down to 4 and 3, 2 and 2. So there's my product of primes. And 27. 3, 9, 3, 3. 1, 2, 3. Alright, now watch what happens here. You might like this. Alright, we have a 2 there, a 2 there, and a 2 there. So 6, 2 goes into 3 one time, so I bring 1, 2 out, and I'm left with a 2 in there, right? Because I pulled 1 out and I have 1 left over. Can't do anything with the 3, so it stays there. So 2 goes into 2 one time, so I bring 1, 2 out, and there's no remainder, so those go away. And that square root of 3 stays in there because I can't do anything with it. 2 goes into 3 one time, so I bring 1, 3 out, and I have 1 left over. So that 1, 3 stays in there. So that's 12. That's 4. That's 15. Okay. 2, 4. Okay, so if I did this right, that's where I'm at. I've got a square root of 6 here. I can't do anything with it. I can't combine it with these because it doesn't have the same radicals. So I'm just going to leave it alone. It can't combine. Negative 4 plus 15 is a positive 9. 15 minus 4. Nope, I'm sorry, not 9. 11 times the square root of 3. And that ends up being your answer because these two cannot combine. Okay, so let's look at a stinking hard one. Let's do 56. And I don't think 56 is really that hard as much as it looks like it. When I was teaching high school, I was always telling my kids to go home and ask their parents to help them with their math, because then it would make them feel really good that they knew so much more than their parents did. But now that I'm teaching college, some of you are those parents, and now you can start helping your kids with their homework. Alright, so again, we're going to make that into the product of primes, so we're going to say, okay, what times what is going to give me 44? So when I factor it down, I'm not going to use the factor tree. I'm just going to write it on here. 2 times 2 is 4 times 11 is 44. Okay, I have to make my writing smaller. 99. Let's see, 3 times 3 is 9 times 11 is 99. And again, see, I'm just doing the product of primes. Now 176, I can't do that in my head, so I'm going to do that and then put the answer down after I get done pausing. Okay, so there it is. 2, a 2, a 2, a 2, and an 11. So 2 to the 4th power and 11, and then our x cubed y. Alright, so I hope that by breaking these down into their prime factors helps you to maybe solve these better when you have numbers. And you know, the only time that you have to worry about it is when you have numbers in here. Alright, so let's go ahead and see what we can do to put this together. Okay, so we have 6, and that's an index of 2, so then we just go in each one and see how many times it goes into that. So 2 goes into 2 once, so I pull this 2 out. This 11 has no exponent, so it stays in. Whenever a number or letter doesn't have an exponent, it never comes out. You just leave it in there. 2 goes into 3 once, with 1 left over. 2 goes into 3 once, with 1 left over. Now let's go to this one. 8x, that just stays there. And that's a 2, remember, so 2 goes into 2 once, with nothing left over, so there's no 3's left. That 11 stays in there because it doesn't have an exponent, and the x doesn't have an exponent. 2 goes into this 2 once. Alright, let's go to the last one, 6y, and let's see, there's a 2 there, so 2 goes into 4 twice, so I pull 2 2's out. and nothing left over. The 11 stays in because it doesn't have an exponent. 2 goes into 3 once with 1 left over, and the y doesn't have an exponent, so it stays. So let's multiply everything outside of the radical sign. Whoops. Tried to multiply 6 times 2, but what do I have? 6 times 2 squared, which is 4, so 6 times 4. Little mistakes like that really can screw things up. Alright, so this cannot be added to anything because notice it has an 11x, and these both have 11xy's. So these two can be combined, so 12 minus 24 is negative 12 xy square root of 11xy, and this part here just gets tagged on. We can't do anything with that. You cannot add those two together because this does not have a y like we do over there. Okay, so that's probably one of the hardest ones, so you should be good with the problem set 8.3 now.